So, indeed, I am a regional sales manager for at Sensefly for the past 2 years and a half, and I've been working with this exciting product, which is a fixed-wing drone. We've talked a lot here about what to do with data, what to do with the 3D renderings and the different interests that it has. Now, today I will talk to you about how to gather this data, how to gather all these pictures and to create an orthomosaic. So, Sensefly has been around since the beginning of professional drones, so about 10 years ago, with a first lightweight drone called the Swinglet. Um, the main aim behind Sensefly drones is to remain a very lightweight product in order to be able to fly above people, to be around in mapping that require a product that will not be dangerous to be used and easy to use. That's really the focus of the company. So since we've been around, we have over 1 million accumulated flights worldwide. We operate a bit everywhere. And as you can see underneath, there has been constant evolutions to our flagship product, the EBX, since it is now the 6th generation of drones that has been released by Sensefly. To give you a little map of this evolution, it started with the Swinglet, that had only a 20-minute flight time autonomy and could only resist to a wind of 6 meters per second. Then the EB Classic, that has been released in 2012, more than doubled its autonomy and its resistance. So the aerodynamics has been completely reviewed there. And 2 years later, the RTK PPK option has been added to the drone in order to obtain a centimetric accuracy. 2 years later again, the EB Plus was released. So this one has an autonomy of about an hour, which is the current standard autonomy of Sensefly drones, and added the possibility to have interchangeable sensors, allowing you to do a lot of different type of missions. I'll get into the sensors a bit later on. And then in 2018, the EBX has been released. It can go up to an hour and a half of flight time with high-performance batteries, and added the possibility to do thermal imagery. Regarding the platform itself, so it's three main things: the drone and its ground modem, the sensors, and the softwares around it. So the drone is, as I said, light, between 1.3 and 1.6 kilograms, depending on the sensor and the battery you're using. The operational range can go up to 55 kilometers. And what is very important is the design of this drone was completely to make the maintenance easy. So everything is detachable, and most of the repairs can be done by yourself. The wings can be removed, the upper body can be removed, the lower body can be removed, allowing you to really just, it's plug and play. You buy the parts and you plug them as you need. It is extremely robust and light, so it's EPP, so it's a foam essentially. And the deployment of the drone, if you already have your flight plan that is made, it's roughly about 3 minutes. It is sold with a backpack or a hard case, depending on the type of solidity you need. The backpack can be used to go in difficult terrains, for instance. The sensors now that I'll present in further details in the next slides are interchangeable. So you can really plug and play any sensor you want, depending on the type of mission you want to be running. The main families will be the RGB, thermal, and multispectral type of imagery. And finally, we are offering some processing softwares with it, which are Pix4D at the moment, but it can be used also with Agisoft or Metashape to process your data. Emotion is the flight planning software, and it's a big strength of the system since it's extremely user-friendly and allows anyone who does not have a piloting expertise to be running the drone. Here are the sensors that are available at the moment. So, as I said, the RGB ones. So here, AriaX, Soda 3D, and Soda. Soda being the standard RGB sensor, AriaX the high-quality one, and Soda 3D allows you to take oblique pictures to get better 3D renderings. Then we've got the thermal with the Duet T, and the multispectral Red Hat MX that is mostly used for agricultural purposes. Sorry. Regarding the Soda 3D, which is really a specificity to Sensefly since a long time, it's a big strength in our sensor family. It's very specific because it does not take only nadir pictures, but also two oblique ones at 40 degrees. This can be modified, by the way, the angle. The idea here is not only to increase the coverage tremendously, which is of roughly 150 hectares per flight with a sensor taking only nadir pictures, to 500 hectares per flight using the Soda 3D. The second objective here, of course, it's when doing a 3D rendering, the main limit to drone imagery is by taking only nadir pictures, you cannot get the facades, the vertical surfaces of your map. Using oblique pictures, of course, you can get that. This is an example of 3D rendering that has been done above the city of Lausanne. I apologize, there's some construction work in my building. I hope this is not too noisy. So this is an example of mapping that has been done with one of our drones. This is a flight that was roughly 15 minutes. It's extremely efficient for urban mapping. At the moment, it's still fairly limiting to do urban mapping since most cities in Europe require specific authorization to fly above people. But this is our aim, to make the tool accessible to all geospatial experts or workers around here, to have a tool they could use in cities like this for such missions. In some countries, like Canada or Brazil, we already got the authorization to be flying above people. And we are working hard to get that done also in Europe. Another point, by using a drone that is lightweight and has a long autonomy, is to be working on the BVLOS, what we call beyond vision line of sight. So at the moment, the legal range is limited to a kilometer, but this can be extended. In England, for instance, they already allowed extended vision line of sight, so going to up to 2 kilometers. And we are expecting this range to increase in Europe in the near future. The Duet T is a thermal sensor that is also used a lot in urban mapping and construction work to assess the water pipe, for instance, the heating system of a city. This is an example of usage. The idea here is the sensor is a combination of our SODA, so a standard RGB sensor, and a thermal sensor, which is a FLIR, and they are coupled together. The idea here is to get a better accuracy when reconstructing the orthomosaic. For a simple reason is that the resolution of a thermal sensor is far inferior to the one of an RGB. And when reconstructing the orthomosaic, the software can sometimes struggle with only thermal imagery. So here, since the two sensors are coupled together, you can get you take the same pictures, one RGB and one thermal, and then you reconstruct the orthomosaic using the RGB pictures, and then we just match the thermal imagery. We have the same system with multispectral sensors, by the way. This is an example of a city in Switzerland, Bonthoux, where we did this mapping by night to help the city, and this is a very current topic, to help the city work on their heating system. They want, it's an ecological thing that they are doing in the city. They want to change a bit the way they are heating it, to find if it's as efficient as it could be and if it could be improved. And this type of mapping is helping them work on that. So here on the left, you have the imagery RGB taken with the SODA and the corresponding thermal imagery on the right taken by the FLIR sensor. And to finish, I'll have 2 slides regarding the regulations, because this is a big topic when using drones, especially fixed wings. It's a professional drone. It's not as easy to use as a quadcopter, or at least that's the first impression you can get. So it's important to understand what are the regulations we are working with. And in Europe, there is a big topic of the European regulations that is harmonizing the rules to operate such drones during between all the member states. This is very important for us, and we are very close. We're working very closely with all the deciding authorities in this regard, since we want to be on the forefront of any changes in the regulations. The timeline has slightly changed in some countries because some countries requested to push it a bit further, UK being one, Belgium being one, France being one, but essentially the logic remains the same. We will have a transition period of 2 years, during which the limits will be the weight, essentially. So the things to remember is the regulations will change whether you are operating under 500 grams, under 2 kilograms, and under 25 kilos. This changes the rules of engagement with a drone, and what you can do with it, if you can fly above people or not, for instance. And after this period of transition, these categories will remain the same, but will change slightly in their limits. So the 500 grams limit becomes a 900, the 2 kilograms becomes a 4 kilos, and the 25 remains the same. The reason is simply because during the transition period, there won't be as many other constraints than the weight. So they just they prefer to be more careful than sorry by making a weight limit that is more severe during the transition period. So we remain under that at the moment. This is the limited open category. So during the transition period, we can fly at 120 meters of altitude, 2 kilograms maximum. We operate at the moment in VLOS, so vision line of sight. We have to see the drone to operate it. And we have to operate 50 meters away from people, from uninvolved people. We will be in the A2 category, so in the between 500 grams and the 2 kilograms. And after that, after the transition period, the limit of 120 meters of altitude flight remains not unchanged. The drones will be able to be up to 4 kilograms, and the limit is 30 meters away from people to fly. Considering that if the drone is more than 4 kilos, you have to operate 150 meters away from people, from uninvolved people, which is essentially off-site. It's the same during the transition period. If you're above 2 kilograms, you have to fly 150 meters away from uninvolved people. So all in all, this was to conclude my presentation. I wanted to show you a lightweight system that is very easy to use and very versatile, that can serve many purposes. Whether you want to create an RGB orthomosaic and 3D rendering, or a multispectral or a thermal one for any mapping needs you may have. I can be contacted directly if you have any further questions, or if you require sales information on the system or even a demo. We are always able to help you and have local presence everywhere in Europe. Thank you very much for your attention, and I wish you a great day.